In 703, we're going to have a look at what we call linear modelling, which just means we're now applying those mathematical concepts that we learnt about the linear function in a real life situation. So I'd mentioned that before, that the reason that the maths was developed, that algebra was formulated, was so that the scientists had some mathematical way of representing what they were finding. They were finding there were connections between force and distance, or force and speed, and lots of other things as well. So you're going to be asked questions like, what does the gradient represent? Now, that is a different question to what is the gradient. If you're asked to find the gradient, then you're giving a number answer. If you're asked a question like, what does the gradient represent? Then you're expected to give a worded answer, and it might be something like the increase in the population per year, or the decrease in the price per kilogram. How will you know what the worded answer is? You have to read the description of the situation, of the model. You have to read the words of the model that they're going to describe in each question. So it comes back to reading well, comprehending well, underlining key concepts. Don't just gloss over and miss out some words. You can't afford to do that anymore. You can't afford to just focus on the numbers. You have to read the words and comprehend them and make sense of the situation. Okay, so like I've said, scientists and researchers often use linear functions to describe patterns, relationships, things that they're observing. So we have real life meaning for what y represents, what m, or the gradient, is measuring, what x represents, and what b also measures. We haven't done a lot on b. There was a whole exercise on gradient. I thought they were going to focus on B, but there's no real focus on calculating B. I guess because B is fairly easy to identify. In an equation, it's the number without an x term on it. And on a graph, it is the point at which the straight line cuts the y, or the vertical axis. And in a table of values, it's always the value here under the x is equal to 0. Whatever this y value here is, that is our value for b, or the y-intercept. Okay, we have some more terms to introduce, and you must know the definition of these terms. Y is defined as the dependent variable. Why? Because it depends, so it's the dependent. This y value depends on the x values. It's depending on whatever x value I use in my equation. That's what the y value is. Then the x variable, or x component of the equation, is the independent variable. Please learn those two, dependent and independent, because you get questions simply asking you what is the dependent variable. Variable just means pronumeral. Now, These are all things that can go in your key points and summary for each exercise and then get transferred into your summary for the whole chapter. It is an expectation that you know that variable is the same as pronumeral, and clearly it's an expectation that you know how to, or which variable is dependent and which is independent. When we come to graphing them, the dependent, now remember that's y, is always placed on the vertical axis. This is vertical, up and down is vertical, and you've been doing that since year 8. The independent variable is placed on the horizontal axis. Now the reason that we're focusing and identifying that is because it won't always be x. This could actually be kilometres. It could be time. It could be years. It could be kilograms. All of these things that it could possibly be represented on the x-axis. Different things that you'll see represented on the vertical or the y-axis are cost in dollars. It could be the population. It could be the distance travelled in time. So these are the real things that are being measured, and you have to be really careful about the wording of the questions now, because the wording could be asking you for a word answer, a sentence answer referring to the cost. So you need to be really careful and aware of that. Now, what does the gradient do? We know the gradient measures the slope of the line. But if I'm talking about population, and then I just go, well, the gradient's the slope of the line, that means nothing in terms of population. In an answer to what does the gradient represent when we have population on an axis and years on the other axis, then you are expected to say the gradient represents the rate at which the population is changing per year or per month. So use the words that are written here to help you then form your sentence answer to such similar questions about what the gradient is measuring. What is the gradient measuring? The answer is not rise over run. That is how you calculate gradient. Find the gradient. But what does the gradient measure or represent is going to require a sentence answer. In these examples, we can see that the cost is being recorded here on the vertical axis, and output. We would say the gradient measures the increase, because it's a positive, increase in cost per unit of output. Over here, again, we've got price and we've got quantity. So 50 items, 250 items, and you can see that the price is coming down. It's a negative. It's a decrease in the price. The gradient represents or measures the decrease in price. Now you don't have to make that word up because it's written here on the axis. We didn't have to make up the word cost, it was written there. We do have to recognise an increase being a positive or line sloping up, or a decrease, negative gradient, line coming down. You need to be able to identify those for yourself. So it's the decrease in price per quantity. Now that quantity could be per 1 unit in quantity. For 1 unit in quantity. Okay. Another way to describe so that was the gradient. A way to describe the y-intercept is, and this is really important, the y-intercept measures the initial quantity. Initial means in the beginning, at the start, at the beginning or at the start. So in example 1 here, the y-intercept is this 8,000 and it represents an initial cost of $8,000. An initial cost. This graph isn't complete, so we can't read off the y-intercept for it. I'll do this example in a video and I'll put it on YouTube separately.